I'll go ahead and get started. My name is Russ, and I'm with Ryan, one of the co-organizers of the blockchain meetup. And so today we were going to talk a little bit about smart contract security in Ethereum. So, I'm not sure in terms of everyone's knowledge about Ethereum, or smart contracts in general. But I thought what we could do is maybe just start off with some quick introductions, maybe introduce yourselves. I know I've seen some of you a few times, some of you I'm seeing for the first time, so certainly welcome. We're excited to have everyone here. And this is just an outline of what I plan to talk about tonight. We can keep it pretty informal, so if you feel like, hey, let's move it on, or you've got questions, or something else we want to talk about, certainly feel free to ask any questions. And again, this is completely informal, hopefully it'll be at least somewhat informative for folks, and not a complete waste of your time. So just a little bit about me. My name is Russ. If you want to get a hold of me, that's how you can get a hold of me. And I will post these slides on the Meetup page, so you can download those, or if you want to get a hold of me later, feel free. I always put a disclaimer on there that I'm by no means an expert, so take everything I say with a grain of salt. So we went through introductions and everything. I guess, does everyone here have sort of a high-level understanding what smart contracts are? We can go through this a little bit, and I know I put a lot of words up there, so it might be best just to talk through it a little bit. But I think it helps to maybe contrast traditional contracts with smart contracts, just so that you can compare them to each other. So, what's a traditional contract? Well, it's basically an agreement between parties or, people. And the key thing is that it's enforceable by some set of laws, based on whatever jurisdiction you're in. And you can also think about it as, it's a promise to do something in exchange for something of value. So, that being said, what's a smart contract? Well, there's probably 50 different definitions depending on where you look, but one definition that I thought was a good one was computer code that automates some aspect of a contract. And there are multiple pieces of contracts that could be automated, whether that's the actual performance of the contract, or some sort of like the actual execution of it, the agreement to it, that sort of thing. Nick Szabo is sort of the father of the idea of the smart contract. He came up with that in 1994, which I feel a little dated too, because that was when I was in college. So it's funny when there's concepts that have been around for a long time, and it's like, wait a minute, I guess I've been around for a little while too. But what he talked about with smart contracts was the desire to minimize trust amongst third parties. With a traditional contract, if the contract goes sideways, you have to get the state involved. You have to get the law involved in some fashion, whether that's a civil type of lawsuit or something like that. But with smart contracts, the idea is that if the contract is automated, then it just executes, and you don't have to get other people involved to enforce it, or to make sure that that it's going to do what both parties agreed to, and it can help reduce costs and improve efficiency. So that's some of the main, I guess, arguments for smart contracts, is that it can automate a lot of the value that's currently in regular contracts. Ethereum, I don't know how. Yeah, did you have a question?
Is there penalties put into the smart track up front? So if they don't follow through, then the penalties go into action?
Yeah, you can, I mean, it's really, it's almost like a contract that has been turned into computer code and that is running on a bunch of computers around the world where everyone is kind of double checking each other in terms of whether or not the contract is doing what it's supposed to do. So you write all those terms into code basically, and then a bunch of computers around the world will run that code, and they should all come up with the same results based on the inputs that are going into that, and that's how everyone verifies it. Yeah, that contract was, was performed successfully. So then you have to write those enforcement mechanisms into the contract, into code. And so, when you think about it, what can code control? Well, it can control computers. So, if you are trying to, develop that into the real world, you have to have some sort of interface with a computer. So one of the companies that we'll talk about here in just a little bit is a company called Slock.it, and they're developing smart locks that are connected to the internet. And their idea is that you can take a smart lock and you can develop no, go for it. You can develop a contract that's tied to that lock, and then let's say you're renting out your apartment on Airbnb, and the person pays you, then that contract can automatically fire, and that lock will unlock, like with a mobile phone app or something like that. So, the contracts that you can do with Ethereum and smart contract platforms are really designed to interface with computers. They control, you have to have a computer somewhere in the middle there to control, some aspect of what the contract is doing. Yeah, that's one way you could implement it. Yeah. So another way that you can implement it is if you have an agreement between two people and there's a smart contract that's there that says, in order to get payment, you have to do X, Y, Z. Otherwise, the funds get returned to the person who originally put in the money. So if the person who, the people who agreed to that contract, if X, Y, and Z doesn't happen, then the money that is locked into that smart contract, automatically goes back. And the whole idea is that that's written into the code so that you don't have to go to a judge and argue and say, hey, I did all this stuff and X, Y, Z never happened, so I need my money back. It's all automated. So that's part of, why it's interesting is that, that it can be automated and no one is going to, I guess, no one can question it, that it's, actually there and happening. So, talking about Ethereum, what is Ethereum? Ethereum is basically a smart contract platform. Now, the description that's listed there is based on what's on their website. And you can see there's a little bit of an asterisk that I've added there, which is a little bit snarky, but we'll talk about why I added that asterisk in a little bit here. But it says, Ethereum is meant to run smart contracts that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. So like what we were just talking about, it's meant to be kind of set it and forget it. You put it on the blockchain, people agree to it, there's an execution based on, you sending it a transaction, and then it executes based on the inputs and the outputs that it produces or that it processes. Ethereum is its own blockchain, so blockchain is sort of a data structure, and we're the blockchain meetup, if you will. So we're all about blockchains and what they mean, what they can do. In this case, Ethereum has its own blockchain that stores and holds these smart contracts. They're these data elements, they're these programs that live on a distributed database that are replicated on thousands of computers around the world. So that's why it talks about it being, censorship proof. Third-party interference can't come in and change it on some computer because all the computers around the world have a copy of that code, and they all are coming to consensus based on the data that's in that blockchain. Now, I put an asterisk up there because recently, I think probably a lot of you have heard about the DAO, which is something we'll talk about here in a second, but the DAO is a smart contract. It is a smart contract on Ethereum that is in the process of, it was hacked basically, and right now it's up in the air what the Ethereum community is going to do with it. Yeah. Yeah, it's certainly up to.
As far if I may add, as far as the Ethereum smart contract goes.
Yep.
In a contract, you have an agreement, and in that agreement, sometimes you can change a word, and the agreement just completely changes. I'm talking about a real agreement.
Yeah.
What happened with this hack was exactly the same thing. They just changed a value in the code. It changed completely. It became a legal hack.
Yeah.
And I think that's an important part to point out.
Yeah, we'll definitely get into that here in a second, talking about the DAO and what happened with it. Right now Ethereum is debating whether or not they're going to do what's called a hard fork, which means they're basically going to reverse the DAO's hacking. They're going to reverse the history of that smart contract and try to refund all of the money that's associated with it. So that's in process right now. They're working on that, and so far it looks like the Ethereum community is going to go along with that.
It's called a hard fork?
Right. Yeah, and the reason it's a hard fork is basically you're making something that was valid in the past no longer valid. So you're kind of rewriting the rules of the system. So you'll hear the terms hard fork and soft fork. Hard fork is something that like I said, kind of rewrites the rules of the system. Yeah.
Who gets to make that decision?
Well, really it's the entire community, the entire user base, and people who are in the Ethereum community. So there are a lot of different stakeholders. Obviously, there's people who are Ethereum holders, people who hold the Ethereum currency. There are people in the ecosystem like developers who are influential in it. There are people who are just interested in it and follow it and participate in the community. The miners who mine the Ethereum blockchain are probably, they have a lot of influence because they're the ones who basically get to decide what's valid and what's not valid. And for the rules to be changed, the miners have to all agree that they're going to run a new version of software that has those rules in it. So, really, there's not any one particular person who's making the decision. There are people who are advocating for it, but it's up to Ethereum as a whole, as a community, to decide what they want to do. Yeah, and we can talk about that here in a little bit. But yeah,
like a group at the top that actually makes the transfer Ethereum.
yeah, there is there's an Ethereum, I guess, foundation. Right, yeah, and there are organizations out there that do Ethereum development who develop the protocol for Ethereum. And so they have a lot of say, they have a lot of expertise in saying, hey, here's what we recommend, or here's what we think, you can do, here's your options, if you will. So we talked about the DAO, but, what is a DAO in the context that we're talking about? You can read this, it stands for Decentralized Autonomous Organization. Sometimes they're called DACs or corporations. And, by decentralized, it means that it's not controlled by any single entity or group. Autonomous meaning it's self-executing, which is kind of an interesting concept with computer code. It's autonomous, meaning that it's controlled by code, not by a human making a decision. Now, that code could be based on input from humans, but at the end of the day, it's code that's running as opposed to, like a human kind of decision-making process. And then, an organization or a corporation, you think of it from a kind of a legal standpoint, where a corporation is an entity. It's a legal person that has legal standing to make decisions. And that's kind of the idea behind a DAO or a DAC, is that you can have this computer code that's kind of running on its own, almost like artificial intelligence, and it's doing what it's doing without the intervention of, outside, groups. So what is the DAO? Well, the DAO is basically it is an attempt to create an instance of a DAO, and it's not the best name for it. From what I heard, the team that was putting it together said, well, what are we going to call this organization? And they just said, well, let's call it the DAO for the time being until we come up with a better name, and it just kind of stuck. So the DAO, as it's being referred to now, it's an Ethereum contract. It's designed to act as sort of a crowdfunding mechanism. So it's meant to raise funds from Ethereum, people who hold Ethereum currency. And then there are a set of functions within it that are designed to solicit proposals from people in the community, verify those proposals, have the people who participate in the DAO be able to vote on them, and then the DAO, if that vote passes, it'll pay out funds to those proposals, and it's kind of like a venture fund, a VC fund, where it's paying out money to projects to improve the Ethereum infrastructure and basically make money for the DAO. And then if those proposals are successful, the money that those projects raise will come back to the DAO and get redistributed out to the people who hold the DAO tokens. So I talked a little bit before about Slock.it, and Slock.it has been involved in the DAO pretty much since its formation. So if you hear them talk about it, they'll say, no, we're not involved in the DAO. We helped set up the DAO Framework, which is kind of like the source code for it, but we didn't launch the DAO. It's its own entity. We're at an arm's length from it. That said, they have been heavily involved in marketing it and promoting it and talking about it, and they've kind of been the representatives of it in the community. So I think it's pretty clear that they do have an interest in it, and they also, if you go look at the DAO webpage, they were the only project that had a formal proposal that was on the DAO's list of proposals. So, they're kind of tied at the hip to each other, even though Slock.it says, oh, that's not us. So what does the DAO actually do? We talked about that just a little bit. It receives investments from the community. It distributes DAO tokens. DAO tokens are basically like shares in the DAO. And the more tokens that you hold, the more share you get in the DAO. The more votes that you get, or the greater the share of the vote that you get when it comes time to vote on proposals. And then, like I said, the community, the DAO token holders will vote on proposals, and if the proposals pass, it'll distribute funds to those proposals, and then if those proposals make money, that money goes back to the DAO. So, again, we're talking about the DAO in the context of the fact that it's just been exploited, it's just been hacked, and whether you say that that's legal or illegal is kind of, up to your point of view of it. But, I would say fairly soon after the DAO came out and was being talked about, there were, I think, a lot of people who were looking at it and saying, this is a little suspect. There's some issues here with how this is set up. And, there's a link to a blog post that's there on this slide. Again, I'll send these out. But there were a group of researchers who identified a group of deficiencies or weaknesses in the DAO that run the gamut from misaligned incentives to game theory sort of issues with it, and then there's obviously security issues with it that were found. So this is just a list of some of the weaknesses that were identified in the DAO. There's a bias in the DAO that because of the way that the voting mechanism is set up, people are biased towards voting yes. If they vote yes, then they get to participate in the process. If they vote no, then they basically their vote is locked in, and they're restricted from making additional votes at that point. So it kind of pushes people towards voting yes. There's an issue where people who say, if there's a proposal that's out there being voted on, and people say, that's not a great proposal, I'm going to vote no on it. If not a whole lot of people are voting no on it because people see it's not a great proposal, someone can come in at the last minute and put a bunch of yes votes on it and kind of steal away that vote. So there's some issues there with the mechanics of voting. If you have someone who controls a lot of the DAO tokens, they can manipulate the token value in order to manipulate who's controlling the DAO voting process. One of the interesting things is that when you vote yes for a proposal, you kind of get trapped in voting for that proposal. So if someone else comes in and let's say they put out a silly proposal and you just say, okay, yeah, I'll agree to that, and then someone else comes along and says, all right, I'm going to put out a proposal to give all the money to myself, and oh, by the way, I control the majority of the DAO tokens. At that point, because you've already voted yes for that current iteration of the DAO, you can't get out at that point until those votes are finished. So you're kind of stuck in that bad vote, if you will. So those are, again, they're design weaknesses. They're not the reason that the DAO was hacked, though, and we'll talk about that here in just a second. So getting into the hack itself, and this is a little complicated. I'm going to try to describe it as best as I can. But if you're interested in it, there's a website here that goes into excruciating detail about how the hack itself actually happened. But there's a function within the DAO that's called split DAO, which is really it's there so that if you disagree with the decisions that the DAO is making, you can split off and form your own DAO, and then eventually, if you want to just get your money back, you can get your money back. It's designed to allow you to get out of the DAO. So there's a function in there called split DAO that calls a number of sub-functions that will let you pull your funds out of the DAO. So the basic idea here, and this is called a reentrancy bug, or this blog here calls it a race to empty attack. What it is sort of, the computer science guys here know recursion, right? So if you're calling a recursive function, you're kind of calling yourself multiple times. So what this is that if you have a smart contract that calls an external function, a function outside of that contract, that function can then call a function back within that same smart contract that called the other contract. So it's sort of like, it's almost like playing a game of telephone or something. You're the smart contract. You're calling another contract that's, out on the blockchain somewhere. That contract, whenever it gets a phone call, it automatically redials, say your cell phone number. So, you call that contract, and all of a sudden your cell phone starts ringing. And it's able to do that in sort of a loop process. So if you're not careful about how you associate funds, so in the case of the DAO, this is a function that is meant to pay out what you had in the DAO to start off with, and the earnings that you are entitled to as being part of the DAO. So it's basically calling a function that says, okay, I'm going to pay out whatever you're owed. Well, if the contract that you're sending that to has a function in it that automatically calls that payout function, and if you're not careful about how you write that function, then it's just going to get into a loop, and it's going to call itself multiple times, and it's going to pay you out multiple times because it's not keeping track properly of what it's paying you. So this is, and I'll show you some examples of it here in a second. But it basically comes down to you're doing things out of order. If you're sending someone some money and you've got on a ledger that you owe this guy $20, if you're sending him money, you're deducting on the ledger that you're sending him the money, and then you're sending him the money. Because if you don't deduct on the ledger that you sent him the money and then you forget about it and he calls you up and he says, hey, you still owe me the $20, then you don't know that you already paid him. You're going to say, okay, here you go. So it's kind of that same kind of a thing. Someone is telling you, hey, you still owe me $20, and you're continuing to pay him out even though you already did that. So, this is probably a little difficult to read up here, but this is an example of what we're talking about. And you see there's 3 different functions up there. The function that's circled is called withdraw balance. So this is a function that is sending some sort of funds to another contract. That third line that's got the part underlined in red where it says message sender call value, that is where this smart contract is calling another contract to say, all right, I'm going to send you whatever money I owe you. And then you can see that fourth line, that second line that's underlined where it says user balance equals 0. That's the part that came last in the sequence. So that's the problem. If you're sending money to someone, you need to tell yourself, hey, I sent that money already. You need to set that to 0 first, and then send them the money, and then have the ability to recover from that if something happens to it. So that's the basic idea. This is a simplified example, but this is the basic idea of what happened with the DAO. This would be an example of that separate contract that the first contract is calling. So you can see that call that's underlined in red there. It's calling that original contract. So it's basically creating a loop now, and it's saying, all right, I'm going to call back to the original contract and tell it to withdraw again. And meanwhile, that contract hasn't finished what it was doing. It hasn't deducted the original money that it was supposed to send you, and it's going to just keep doing that until basically it runs out of gas or there's some other exception that gets thrown. So, again, this is kind of what, when you think about a programming stack, or when in Ethereum you can have these call stacks where you get these multiple functions stacked on top of each other. So you can see the first contract that runs is that vulnerable contract that was doing the withdraw function. So it runs the first time, and it calls the attacker contract. The attacker contract, in turn, calls the vulnerable contract again. The vulnerable contract, again, because it's creating another instance of itself, it's saying, okay, I'm running again. I'm not keeping track of what the balance is here. I'm going to call that same contract again. So you can get these, basically these nested function calls, if you will, almost. I mean, there's a limit in Ethereum that you can only get up to. I think it's 1024 function calls at one particular instance. But you can imagine if you're withdrawing $100 each time, that's a lot of money for each one that you call. So, and if you do it right, you can do it multiple times, and that's basically what the attacker did with the DAO. So this is the actual DAO code, and I'm not going to go through it because it's basically the same kind of process that I just described. But the first line that you see here is basically the code that's getting run multiple times, and then the second line that's underlined there, where it says withdraw reward, that's where it's sending the reward for that token holder out to that contract. So that's where it calls that malicious contract, and then the malicious contract re-enters this function again and just sets it up multiple times to run. So this is from that original blog that I shared a link to, talking about what happened with it. Again, this is all centered around the split function with the DAO. So this is meant to get money out of the DAO because you want to go in a different direction. But it ended up being an exploit where someone who read the code really closely said, hey, wait a minute, there's this behavior that's not really been defined, and if I call this contract with another contract that I've specially created, it's going to create this loop. And it's if you go by the original language of the DAO on their website says, our code is our law. We will not bend to anyone else. We will do only what the code says we will do. And well, that's what happened. The DAO executed. Someone figured out that you could get a bunch of money out of it. And, there was a Pastebin post. I think that the hacker actually posted something. I don't think that it was ever proved that it was the actual hacker. But someone who claimed to be the hacker put a post out that said, I've reviewed the code of the DAO, and per the terms of the DAO website that says that the code of the DAO controls everything, I have executed the function that allows me to withdraw money multiple times. And I've consulted with my lawyer, and he's told me that that's perfectly legal under U.S. law. So he's kind of being a troll, frankly, but if you go by what the DAO said on their website, it's true. That's what they told people. And now that you have upwards of $150 million worth, or at least that's what it was worth at the time. Now it's, I think, less than that, but it's basically about 3.5 million Ether that were pulled away by the person who exploited this bug.
We don't know the identity of the hacker. I mean, it's not possible.
I'm sure that they went through steps to protect their identity. It could very well be. I mean, the thing was that like I was talking about, a lot of people were calling out these issues with the DAO, and there were a lot of security researchers because the DAO had $200 million worth of Ether in it, so that's going to attract a lot of attention. There were a lot of security researchers looking at it, and there's one particular security researcher. I've linked to a lot of his blog posts. He's a professor at Cornell. I think like a day or two before the hack, he reached out to the Slock.it team and said, "Hey, I think we found a vulnerability here." And the Slock.it guys had tried to fix an earlier problem that they found with it, and had, I think, created a proposal for it, and the proposal didn't go anywhere. So it was stuck. Not that it would have prevented this, because this exploit was still in there. It wasn't fixed by what they had tried to fix, but it's it's kind of this thing, again, where you have a question.
Would you consider that now, since you explained all that answer the question that the gentleman asked over there about smart contracts and changing last minute things that you do not want or things of that? Do you think that it all comes together now?
Well, yeah, I mean, and I kind of put some of this, right? Yeah, I put some of this towards the end of the presentation, so we can talk about it in a little bit. But yeah, I think it does kind of call into question, when you have a smart contract, how binding is that really? Well, it's as binding as the system that it runs on. So if the Ethereum community decides that there's a contract out there that they think is a problem, they can band together and do something to change that, and that's what they're doing. It looks like with the DAO. Right. Yeah, I think. Yeah, the deadline is later this month. I think it's like maybe July 26th. That they have to have the hard fork in place, or else the hacker can start getting money out. So that's they're under a time crunch to get it resolved and figure out what they're going to do.
And the hard fork kind of illegitimizes the whole thing, right?
Yeah, so the idea behind the hard fork is that they're basically going to replace the existing DAO contract with a new contract that lets anyone who's got DAO tokens send them back to that contract and get the Ether that they originally put in. And it's a little bit more complicated than that, but that's the general idea behind it. So that's, basically rolling back this entire episode, which, it all depends on how you look at it. If you're someone who invested in the DAO or Ethereum, then you probably are in favor of it. But if you're someone who believes that shouldn't be changed just because someone lost some money, then you may not agree with that.
Isn't it the case with all the technologies right
Right. Yeah.
We have to give it that benefit of doubt.
Yeah, it's definitely, in Bitcoin, when it was getting started, I mean, it had a bug that allowed someone to generate, I think it was like 92 billion Bitcoins, which is, thousands of times more than the number of Bitcoins that are supposed to be allowed. It was one of these kind of integer overflow bugs that someone figured out, and they generated 92 billion Bitcoins. And, the Bitcoin community at the time was extremely small. I think this was in 2010. And no, this was even before Mt. Gox. This was something where someone figured this out and created, 92 million Bitcoin or 92 billion Bitcoin. And so, the community, kind of like Ethereum is doing at this point, they said, all right, that was a bug. That was not the intended functionality. We're going to introduce a fork. And it was not a hard fork in the Bitcoin case. It was a soft fork. But
the only difference is the value.
Right.
Involved, it was like so much different, so much less.
Yeah, it was.
Bitcoin, it was like the very first.
Absolutely.
So now, since we're talking about blockchain, I think it's important to note the difference of blockchain. This one, Ethereum, Bitcoin, and the rest. There's going to be many of them.
Yeah.
But the question is, which one is the best? And now we are seeing the proof of which ones are those. I think that Ethereum is, like you said, it's good. It's just part of the process. It's very good. Ethereum is very good. It covers something that Bitcoin's blockchain doesn't cover, which is the application of distributed apps. But like I said, it's important to notice the difference of blockchain.
Yeah.
Also, as you can see, anything that is attacked is the one that is most unique. Like you will see a lot of biases for Microsoft, PCs versus for Unix machine or Linux machine, right? So it's just like more people use it and it's more popular, then they go after it. So this kind of shows that Ethereum is like the top of the right? So
This is amazing. Amazing technology. This is brand new. This is another thing. This is brand new.
Yeah.
It's never existed. So of course it's gonna be fun,
Yep.
The thing is, believe in it. It's good.
Yep. So one thing you might be asking yourself, if you know something about Ethereum, is there's something called a gas limit. It basically says you can only do so many transactions based on the amount of gas that it uses. And so someone might say, well, what about the gas limit? Well, in this case, it all depends on what function you're using when you're sending funds. So you can see up here, there's kind of a couple of different methods for sending funds from an Ethereum contract. One of them is the send function, which is sort of the, I guess, default or more standardized function. And it's got a very limited gas quantity. So you really are limited to only being able to send something, send a transaction or send a call, send funds to another contract, and then really can't do much else other than that, other than maybe log itself. But the whole point of Ethereum is that it should give you flexibility to do whatever you need. So there's another method here that's called the call value function, and that's the function that was used with the DAO. The call value function doesn't have a limit on it, so that in some ways, in this case it was a weakness because it allowed the attacker to continue to run that function over and over and over again using the same gas that it sent as part of that first transaction. If the withdraw funds function had used the send transaction or the send function, then this wouldn't have been possible. But because they used the call value function, it allowed it to do that multiple times. So this is kind of just a final wrap-up of the DAO. it was a highly complex. It is a highly complex contract. I think it's if you total up, I don't know how many lines of code it is, but it's probably over 1,000 lines of code in a single contract. It was a contract that was evaluated by everyone in the Ethereum community, including the guy who is the quote-unquote father of Solidity, which is one of the Ethereum programming languages. He blessed it and said, "Yeah, this looks good." Despite that scrutiny, it was still deeply flawed. Obviously, it's got all these weaknesses with it, and it still had that security, issue with it that allowed this to happen. Now, I'll editorialize here a little bit. I think that the DAO was sort of a contrived attempt by Slock.it to get around the whole crowdfunding mechanism. And again, the DAO was meant to be sort of a decentralized crowdfunding, like a Kickstarter. But I honestly think that, Slock.it had sort of set this up from the beginning to benefit them so that, they could get money from it. And they themselves even said, "Oh, we never expected that it would get this big. We expected maybe, $500,000 to get put into it, not 200 million." And we've been talking about it, but I think it has created a crisis for the Ethereum community because, now they have to figure out, are they going to do this hard fork? What does that mean? What's the impact of that going to be? This is another list of incidents. There's a list that you can find online. These are more examples of smart contracts that had security issues. So I'm not going to read through all of them, but you can see it's not a tiny list. There's quite a few issues there. A lot of them with similar types of things where people didn't code it carefully enough, and it got out onto the blockchain. Once you put a contract out onto the blockchain, there's really no way of pulling that back unless you build in a specific mechanism to do that. I think the funny one up there is the rock paper scissors contract that I guess the first person to move, the first contract to move, shows what it's going to do, which is kind of the point of rock paper scissors. But it just kind of goes to show you that again, this is very very early stage. We don't know yet all of the security best practices. We're starting to learn a lot of these by trial and error and mistake. But yeah, this is something that fortunately is not uncommon yet. So, we've been talking around this a little bit, the 3.6 million Ether question, which is, the amount of money that was stolen from the DAO. Given the current state of the art with Ethereum and smart contract development practices, what can you do to make sure that smart contracts are safe and secure? So this kind of gets at the heart of, if you're building a smart contract, what do you need to do to make sure that, you're not going to get hacked, or that the people who use it are not going to get hacked, or that, it's not going to have some huge bug that ends up blowing things up, and then you have to go to Vitalik Buterin and plead your case to see if they'll do a hard fork.
What did you just say? What are those two names?
Vitalik Buterin, he's kind of the founder, if you will, of Ethereum. So he's the guy who I think originally came up with the idea of Ethereum as... he's not a doctor. That you're thinking of Gavin Wood, I think. Gavin Wood is the PhD computer scientist who sort of designed the low-level Ethereum virtual machine and system. And then Vitalik Buterin is more of kind of this wonderkind. I think he's probably 20 right now. Yeah. Young guy, obviously, but extremely smart, and he's basically the person who kicked off this whole process of starting up Ethereum. So the rest of this presentation really starts talking about what are some of the best practices for developing smart contracts. So, one thing, and a lot of these things, at least for the people who are developers or, computer science people, they'll probably be fairly obvious, or they'll seem like, yeah, that makes sense. But, I think in computer science, you have different philosophies, or you have different intents, almost like threat models, if you will. So if you're running, a simple website, what's the impact if that gets hacked? Well, you might have to restore a backup. You might have to, go to your website provider and start over or something like that. But ultimately, there's probably not a huge impact, just from other people's money perspective. I think smart contracts are a completely different animal. I think you have to treat smart contracts almost like, nuclear reactor code. Maybe not quite at that level, but when you think about it, there was $200 million worth of value in this single smart contract. So, you better be really careful about how you're coding that. You have to expect constant changes to the environment. Things change, vulnerabilities get found, and you have to assume that a contract that you wrote, 6 months ago, thinking that it was secure, is not going to be secure going forward. Once you publish a contract on a blockchain, that's the nature of a blockchain, is that it's supposed to be immutable, notwithstanding, the hard fork situation. Once that contract is out there, basically, unless you've built controls into it, anyone can see it, anyone can access it, anyone can run it. So it's like throwing it out into the wild and letting the wolves go at it. And like I said, it requires a different engineering mindset. If you're just developing, a web app, you're probably not too concerned if the web app crashes and the web browser has to be reloaded or something like that. In this case, people lose millions of dollars potentially. So, preparing for a failure. Any non-trivial contract is going to have errors in it. A 1,000-line program, I think that from what I remember, the typical number of bugs per 1,000 line of code, I think, is something like between 10 and 50 or something like that, if I'm remembering correctly. So, the DAO being about 1,000 lines of code, it was almost inevitable that it was going to have a bug in it. So, you have to be able to respond to those bugs gracefully. And that's, again, something about the blockchain that you have to think about is, once you put that code out there, it's locked in, it's live. There's no going back. Roll out carefully. This is kind of for anyone who is into ITIL, release management and, making sure that all of your assumptions that you built when you assumed you were making this release, that those still hold. You obviously have to test your contracts on a test net type of an environment. One thing that's interesting, there are people who are providing bug bounties. I saw, and I think I have a link to one of them. Someone on the internet on a GitHub said, "Hey, I think you've got a bug in your smart contract here," and the guy who owned the smart contract said, "Yeah, you're right. Hey, here's a bug bounty." So that's one way of motivating people to examine your code to make sure that it's sound. And then,
Facebook and Google, I'm sure all of them.
right. Yeah.
in the process.
Yeah, absolutely. And it's something that, I think mature technology companies do, is they have a bug bounty program. Keeping contracts simple. This goes back to the fact that, the DAO was over 1,000 lines of code on the blockchain. In retrospect, maybe that wasn't the best way of organizing that. There's one idea that you can publish specific functions or specific pieces of the contract on the blockchain that are the pieces that need to be decentralized, and then handle all the other logic in some other program that's on a web server or some server somewhere else. But it's really, and I think this is going to start coming into play a lot more, is that the more complex your smart contract is, the less likely it is that people are going to want to use it, because people will look at it and say, yeah, there's the possibility that there's a security risk here, and how is that going to be controlled for? How are we going to protect against that?
But what about if you are an organization, if you are a company who is running an application on blockchain, then your users don't get to choose, whether they want to. They don't get to see your code, right? And then still a hacker can come and exploit the pieces, right? So then I think the onus will be on you as a company to make sure that it's right?
Yeah, definitely. Yeah, and the reason why I think you want to limit the complexity of at least what's on the blockchain is that that's the piece that you can't change. You can change the other pieces, like if you've got a web interface to some application, if you've got a defect in how someone logs into that web interface, but the core functionality is on the blockchain, you can fix the login page and not impact the piece that's on the blockchain. You don't have to implement the whole contract on the blockchain and make it a huge, complicated thing. Because one, that gets expensive. You have to pay gas for every transaction that you do on the blockchain or every function that you call on the blockchain. But also, again, for this reason, it's a lot easier to change code that you control versus code that is living on the blockchain that you don't control anymore. Staying up to date, this basically is just saying, hey, you gotta keep track, just like with computer security, you gotta keep track and stay on top of security issues. But I think with smart contracts at this early phase, even more so, there are all kinds of changes that are happening, new practices that are being put out to say, hey, here's a defect that was found, here's how you can avoid it. So, if you are dipping your toe in the water, I think it is a commitment that you need to make to try to stay on top of, the latest security issues that are happening so that they don't happen to you. And, we were just talking about the properties of blockchains. One of the properties is that it's, when you have a public function, it's public. And it's out there. It's public. And people can execute it, people can call it, and you don't have control over what people do with your code at that point. So you have to factor that in as you're designing your smart contracts to, make sure that you're taking into account those pieces. So the next part of this kind of gets into some more nitty-gritty, and I'm not going to spend a whole lot of time into it. I've included links in the presentation that you can go to look at more detail about it. There's a great GitHub that was put up a couple of days ago that basically I stole most of the content for this presentation from. So just, most of the stuff I didn't come up with my own. It's from that GitHub. But, Solidity is basically one of the smart contract languages that you can use with Ethereum. The other one I think is Serpent. And so Solidity is basically akin to JavaScript for Ethereum, meaning that it's not a strongly typed programming language. It's designed to be, more user friendly, but it's probably less exact, less secure, less formal than, say, like if you're coding in C or C++ or one of these more formal languages. It's modeled off of JavaScript. So, JavaScript pretty famously just kind of lets you throw some code out there, and if it works, great. If not, well, we'll figure it out, kind of a thing. So Solidity, these are tips or best practices that are specific to Solidity. So first one here, use external calls with extreme caution. This is the this is the issue that the DAO had, again, because the DAO was calling an external contract that it was trying to pay funds to. And anytime you call an external contract, you're basically giving control of your program away to a contract that you know nothing about.
It was calling to the switch. Is that what it was going to?
Yeah, the DAO withdraw function was calling to a malicious contract that called back to it, that was able to get it to run multiple times. So we talked a little bit earlier about send versus call value. Send is much safer if you need to send funds or tokens to another account, to another contract. Some of these may not make a whole lot of sense without the context. You should go and read the GitHub. It's got a lot more detail in it. But, again, you can't make assumptions about what your program is going to do once you call an external contract. And one thing in the code that you can do when you're calling other contracts is, put comments in there that basically say, hey, warning, this is an untrusted contract. Be careful what you do with this, kind of a thing. So again, you need to just be very careful when you're using external calls. We talked about this a little bit earlier as well. Call depth attacks, which is basically there's a limit on the depth of the number of functions that you can call. So that limit is 1024 functions you can call in a nested fashion. So what you can do is, if you're wanting to attack a contract, you can make your own contract call itself 1023 times, and then on the 1024th time, when you are calling a contract that's going to pay out to you, you can call that contract, and basically when it hits that limit, if it has already sent its funds to you and then it tries to call another contract, it'll error out. But by that point, it'll have already sent its funds to you. So really, there's no way around that other than you have to code in, basically you have to check for that in your code. You have to make sure that, that when you call a function that it returns with a successful result. So some kind of low-level things that are just sort of interesting with Solidity. So Solidity doesn't support floating point math. It only supports integers. So you have to be careful if you're doing integer math, integer division, because it always rounds down. And you may not think about that if you're in the middle of doing some complicated formula. That's something that you just have to keep in mind. Yeah, I mean, this is kind of like it's a little. I mean, these are things that are probably going to be improved over time, and it speaks to how early everything is in the Ethereum environment. But yeah, there's no floating point math in Solidity right now. Division by zero. This is kind of another classic example. Solidity returns zero and not an exception when you try to divide by zero. So, so that's something else that you just have to keep in mind. If you're doing a division, you have to make sure that you're checking for zero, because the code isn't going to protect you. So those were some specific things with Solidity. Just a few examples to keep in mind. These are some higher level engineering techniques in terms of smart contract development that you can do to mitigate your risk. So the first thing that you can do is you can design your smart contract to be upgradable. And we've been talking about, once you have a contract on the blockchain, that contract is out there and you can't really call it back. But people are starting to come up with some mechanisms that you can use to call or to be able to upgrade smart contracts after they're being deployed or after they've been deployed. So one idea that you can use is kind of having a registry contract, and all it does is it has references to other contracts in it. So if you have your registry contract and you have, say, 5 different functions in it, you might have 5 separate calls to other functions. And then if you have a problem with one of those functions and you need to rewrite that function, you can do that. You can put it out into another contract and you can update just that particular call. Yeah, if you're uploading that to the blockchain, you have to pay for that with gas. So none of these are free, but these are mechanisms that you can use to create an upgrade mechanism in case you do have a defect that you need to upgrade and you need to make a change to the code that you have out there. So another example here, you can use a contract that basically forwards, it's kind of like a pointer almost to another contract. So you can have, it's a similar kind of idea where rather than calling other contracts, you can do it sort of at a lower level where you're making direct calls and you're passing data over to other contracts. And so, the whole idea is modularization, being able to take specific pieces out of your contract and replace it if they need to be replaced. So another idea that they're starting to come up with smart contracts is the idea of a circuit breaker, or they'll also call them escape hatches. And there's some links up there to some blog posts about this. But one thing you can do is you can kind of set up safety checks, if you will. So if you have, like, for example, the DAO, it knew that it received 10 million Ether, and it can keep track of the balance that it has. So, one thing with the DAO was basically that because of the exploit that happened, it got confused. The DAO right now thinks that it has all of its Ether. In reality, it doesn't have all of its Ether. And so one thing that you can do is program a mechanism for a smart contract to kind of keep track of itself and say, okay, I'm going to keep track of how much Ether I've gotten in and how much Ether I've gotten out. And if I ever get to a point where I've given out more Ether, I think I've given out more Ether than what I've taken in, I know I've got a problem and I need to time out, or I need to stop and go into like a fail-safe mode. So that's kind of what the idea is here, is creating some of those rules to say, I'm going to check myself and make sure that I'm not getting off into left field, like I haven't gotten into some kind of weird condition. So you can build those checks into, functions that are in the smart contract, and that way, it's like it's keeping track of itself. One thing that you can do when that happens, you can either go into sort of a fail-safe mode. Let's say that if you were doing it as a simple mechanism, you could have the contract default to a situation where one person, or there's one key holder who can at that point go in and remove the funds and fix the problem. So you have kind of a person of last resort, if you will, who can fix it. That's maybe not the best thing from a centralization perspective, and also a legal liability perspective. So another thing you might want to do is, like, automatically, if the contract detects this happening, it could convert itself into a contract that says, okay, I'm going to stop what I was doing, and at this point forward, I can only give money back to the original people who put money into me. So that if the DAO had done that and they had run into this problem, then it wouldn't have needed the hard fork that they're doing. That's kind of what they're doing with the hard fork, is that they're having to manually go in and put in this kind of a process. But if you think far enough ahead, you can build this into your smart contract. And, because smart contracts are complicated, you might not be able to develop logic to check for all of the conditions that you might need to. So another thing you can do is you can create sort of crowdfunded or crowdsourced triggers that say, okay, one way of doing it might be with miners. Miners could signal that there's a problem with this smart contract. If miners signal this value in 90% of the blocks that they mine within the last 10 days, then this contract will automatically halt. So you can kind of build those decentralized triggers that could halt in a less centralized way if something like that happens. It's kind of it's starting to get into some more complicated functionality, but it's I think something that smart contract developers are going to have to start building in order for people to trust and feel good that, okay, I can use this smart contract and not worry about my money getting taken. Another technique, they refer to it as speed bumps, which, is kind of just delays in the way that the smart contract processes. And this is something that the DAO has in it currently. So, it's basically saying, okay, if someone wants to withdraw money, I'm going to make them wait 27 days for the next, opportunity for them to do that. Then you start to get into some more technically challenging and computer science type practices that you can do. So static analysis techniques. This is basically analyzing your smart contracts with a separate program that can look for some of these patterns that are known to cause problems. Someone is already doing this. His name is Andrew Miller. There's a group of people who kind of have it's a group of university researchers. Andrew Miller is, I think, a PhD from University of Maryland, and he developed a tool that goes out and scans the blockchain, or scans, I think Etherscrape is the website that it scans, and it looks for actual instances of these bugs that have been found. And so you can see, you probably can't read it real well, but out of the 361 contracts that the program scanned, 32 of them had vulnerable send functions. So that kind of just tells you, the current state of affairs. These are live contracts that are out there that have these vulnerabilities. That at this point, they will always be out there unless someone goes in and removes them. But that's probably not going to happen. And then kind of the last thing that I'll mention in a similar vein is program verification. And this is getting into really kind of the computer science mathematical theory of using a formal specification language and then creating a specification and then verifying your code against that specification. It's frankly very, unless you're into that kind of thing, it's a pretty theoretical thing that it's not theoretical per se, but it's pretty complicated, or it takes a lot of effort to develop these verification tools. But they are starting to be developed. The guy who is the lead developer for Solidity started to work on a prototype for this for Solidity for that formal verification kind of a prototype or a tool that you can use. So that's in the early stages, but that's I think a direction that Ethereum is going to have to go, is to formally be able to prove that yes, this contract does exactly what we say it's going to do. So this is I kind of those are the main things that I was going to talk about in terms of Ethereum itself, Solidity, and the code pieces. I was going to just kind of wrap things up a little bit with, what does this mean for Ethereum in terms of the fact that we now have to take into account all of these types of security practices going forward. So again, this is what Ethereum calls itself, something that can't be censored. There's no possibility of fraud or downtime or interference. Well, we're seeing that actually that's not technically true, because if this hard fork goes through, then they will be censoring the hacker of the DAO. Now, if the entire community is going along with it, it's kind of like, democracy. It's government here. If if the entire country here elects Hillary Clinton or Donald Trump, you kind of have to go along with it or move. But well, yeah, that's another interesting. Yeah, and that's where it starts getting into some of those really interesting cases where, you could bring people to court because, technically, like, what law did you break by exploiting this code that was out there? And, the contract that the DAO put out that said...
It would be kind of like saying, what laws are you breaking by using Bitcoin?
Right.
Well, if regulators come into it, they will find a law that you are breaking. The same thing with this smart contract. If somebody wants to find some law you're breaking, they will find it. So I think we just have to, do things right. Really do your homework. Really know what you're getting yourself into. If you don't know, wait. But if you feel comfortable, you know what you're doing, then go ahead. But it's just like the same thing as Bitcoin, It tells the same history.
Yep. Yeah. And that's where I think that this experience that Ethereum is going through, it's going to define it for a long time. And so maybe some of that ethos of decentralization, maybe that is when you look at comparing different cryptocurrencies against each other, I'm not saying that Ethereum is going to go away or crash or go to zero, but it's something that people will have in mind as they're making a decision about what cryptocurrency they're going to use. And again, Ethereum will have its use cases.
The purpose is much different.
Yeah.
Bitcoin is host its value, and Ethereum it does not. Ethereum it's like he said, it's gas. It's an item that you have to use when you want to build something in this network. You have to have it. There's no other way for you to pay in this system. So as the more people will start building stuff with Ethereum, the more people are going to need Ethereum. But until then,
Yeah. One thing I guess I will say, and again, this is me sort of editorializing, I do think that there has been a tendency within cryptocurrency, Bitcoin I think is not immune from it, but Ethereum, there have been a lot of people who have just kind of come at it with the assumption that this is the best technology and we can do anything with it, and we're going to, and you can do anything with it, but you can also get burned by that. So I think that there's been maybe a little bit of technological hubris or pride about Ethereum, where I think maybe the community, this would be a good thing for the community from the perspective that it gives all of us a little bit of humility to say, look, we know that no one is perfect. We know that what we're developing is not perfect. We know that it has risks, and we're not going to approach this like it's a science fair project. We're going to approach this like it's a serious, scientific and commercial effort that we're going to dedicate ourselves to. So, and one thing with that, some people are calling it into question, the actual languages themselves. Solidity and Serpent is the other major one that is used. So I think there's going to have to be some work done on the languages to support some of these practices that will become industry standard. Just like C++ has evolved over the years. I think we're on, right. Yeah, exactly. So it's going to have to evolve. Some people are saying, maybe Solidity is not an appropriate language to use for smart contracts because it's not formal enough, and that could be legitimate. And frankly, you could have another language get developed in its place as long as it can get compiled into the virtual machine bytecode. You could develop any language you want for it. So again, it's really a lot's open.
Why did they use a loosely typed language like that? They want it to be secure.
Well, my recollection of it is that I think they wanted to appeal to mainstream programmers who are comfortable with JavaScript, because I think most programmers, when they're learning these days, are learning on something like JavaScript. So they wanted to be able to quickly develop a developer community, and the easiest way to do that is if you have a language that's easy to use. So I think that's the thought process behind it. In retrospect, maybe that wasn't the best decision, or maybe they needed to, make it more like Java instead of JavaScript. But every programmer is different. You're gonna, that's just an argument that you will always have between programmers. Is what language do you prefer? So I think it's certainly a possibility that we'll see new languages being developed that are more formal and have more, fail-safe types of mechanisms built into them natively, as opposed to things that you have to remember and include and use templates for. So just to kind of wrap things up, and I put this up. I was a little reluctant to put it up, but I put it up because it might help think about these kinds of issues. I don't know how many people have heard of a trade-off triangle. I think there are a few relatively famous ones out there that basically say that in certain systems you might have 3 attributes that you want to have as part of the system, but you can only pick 2 of them.
College life ones.
Right.
Social life or good grades.
Right. Exactly. And these are a dime a dozen, which is why I hesitated to put this up, because it is a bit of an oversimplification. But I think with smart contracts, this might be something that you could use as sort of a mental model, if you will. A smart contract, you can have a complicated smart contract that has a couple of thousand lines of code in it. You can have an autonomous smart contract that is out on the blockchain and it's not being maintained and it's just out there doing something. And you can have a secure smart contract that really doesn't have any flaws or defects or bugs in it. So as you increase the complexity of a smart contract, you're going to make it more and more difficult for it to be secure. It's just complexity is the enemy of security. Same thing with autonomy. The more complicated it is, or the more that you try to do with a single smart contract, in order for it to get widespread use, people are going to demand that you include those fail-safe mechanisms in it. So that means that you're not going to be able to have a smart contract out there that just lives on its own and is by itself. You're going to have to maintain that smart contract if you want it to be secure.
Yeah, this is probably good for Ethereum and just like blockchain and smart contract technology in general. Just because now this will probably make companies sprout up that just already have all these fail safes on their website. Like, we check your code for this, and this, and we can be like a validating entity that you can just put on your site like as a stamp. And
Yep.
like, oh yeah, we're validated by them, and they check for this, and this. And like, people obviously can demand that in the free market. So that's like already a company that you can make from this tragedy.
Yeah, absolutely. I mean, I think it's going to bring all of this to the forefront, and people who are developing smart contracts, it's gonna be a classical case study of what not to do and how to prevent it going forward. So that's kind of the end of my presentation. And hopefully you found this somewhat interesting or informative. I'll go ahead and end the recording, but then if anyone has any other questions, yeah.